So, hello everyone, hope you're doing really good and welcome back to my channel. Today we are at day 23 of the June Daily Leetcode Challenge and we're again back with a medium level question. Today I'm really happy to show you my solution because I was really proud of the solution because the kind of solution is expected from this question. First of all, like let us say the brute force approach, but then you have to arrive at something like this and optimize approach. Okay, I was really happy with my solution because it was performing really well. Okay, I will show you how that works. First, let's go through the question. That's question 1027, longest arithmetic subsequence. Okay, arithmetic subsequence, this is something related to, I learned I think in CBSE standard what is arithmetic progression basically, but in this case it is a subsequence. What is subsequence, we will understand that separately, but please try to recall what is arithmetic progression. Okay, arithmetic progression basically means that there is a common difference and that increases when we go from one element to the next. Okay, for example, see here, 20, then 15, then 10, and then 5. Okay, that's how. That means there is a difference coming. If you see, if you subtract any one element from its previous element, let us say 15 from 20, if you subtract, you are going to get minus 5. Okay, and the same thing continues. Okay, 20, then 15, then 10, then 5. Okay, and then so on. Okay, now they are talking about a subsequence. Okay, now please try to guess first of all yourself what is the difference between a subsequence and a sub array. Okay, sub array means it should be continuous. For example, I can say that 6, 9, 12 is a sub array. What is sub array? Sub array is an array basically which is a part of array. Okay, that's why it's called sub means part, and array means just like array. Okay, this whole is a real array and this 6, 9, 12 is a sub array. Okay, this also is a sub array. So the length doesn't matter here, but it should be a continuous part of array. Okay, that only matters. That is a sub array. But here we are talking about a subsequence. What is a subsequence? See, they have given a definition here. Subsequence is an array that can be derived from another array by deleting some elements or no elements without changing the order of the remaining elements. Okay, what that means is, see, for example, 3, then 9 is a subsequence because it's a not continuous one. Okay, we are not taking 3, 6, 9. Okay, we are just taking 3 and 9. Remember, 3 and 9 forms a subsequence. But if you talk about 9 and 3, then no, it's not a subsequence because it should be in the same order. Okay, I cannot say that 3, 12, 3 comma 12 comma 6 is a subsequence. No, 3 comma 6 comma 12 is a subsequence. Okay, 3 comma 6 comma 12. The order should be important. That's what they're trying to say without changing the order. Okay. So see, I have just given you the gist of it so that if you already know, you will understand. If you totally don't know, then definitely you should be, hitting it the Google bar and searching about it. Okay, hitting the Google search and searching about it. That's what I would like to say. And here they've given some hints about the arithmetic progression also. So what they're trying to say is a sequence SEQ is arithmetic if, see, that's what I was trying to say. If you subtract one element from its previous element, you are going to get a same value. Okay, I will again show you how it works. For example, see this question, sorry, this example. Subtract, see, 6 minus 3, what are we going to get? 3. What is 9 minus 6? Okay, I will just write it here for you because see, these things are just math. Okay, these are not related to, they are these are math after all. Okay, what is 6 minus 3? It's 3. Okay, then what is 9 minus 6? Okay, I'm just subtracting each element with its previous element. Okay, it's again 3. Okay, now subtract 12 minus 9. What you're going to get? You are again going to get again 3. So which tells me that this is a part of a, you know arithmetic progression. But remember, we are not talking about progression here, we are talking about subsequence here. But in this case, anyway, it's either. Okay, so tell me the length of the longest, arithmetic subsequence. In this case, each one of them is a part of a subsequence. Okay, so the total length is the length of the array itself, which is 4. Okay, now come to this example. See, see, in this case it is coming 3. It need not be 3 always. Okay, it can be negative one also. Okay, that is what we are going to see here. For example, see here, 20. I'm subtracting 5, here I'm getting 15. I'm subtracting another 5, I'm getting 10. I'm subtracting another 5, I'm going to get 5. Okay. So the length of the longest common subsequence is, see, basically consisting of these elements. Okay. So it's basically 4. Okay. That's what it is all about. And let us see the solution. So the first solution, free. So when, see, this is a real example of a question which you can get in an interview. Okay, so my advice will be, please try a brute force approach. That's what I did basically. I also tried a brute force approach, and finally I arrived at an optimized solution. Okay, that's how the process should be. Okay, so let us see what it is. So I am declaring a mapping here. Basically, what is a mapping in Python? See, whenever we talk about dictionary, it's basically a mapping. Mapping means a value is mapped with a key. Okay, when I put the key, I will get its value. Okay, that is what is called a dictionary in Python. Okay, then I'm taking the length of the nums array given to me. Okay, then I'm using two for loops. So basically, it's going to be a O of n square approach, which I've already mentioned here. But please try to understand the what is happening here. Okay, what is happening here? If you try to understand that, definitely things will be much easier for you. Okay. See, I am going for each element I in the given array. Okay, please focus on my words. Okay, I'm going through each element I of the given array. Okay, then I am going to start a search. Okay, from its next element till the last element. Okay, if my current element is I am going to move j from I plus one till the last element. Okay, that is clear now. Okay, what I will, for example, see. Suppose I am at three. Okay, so this part of the code, okay, this part of the code will be executed for all the next elements. Okay, all the elements right of three. Okay, so suppose I'm at six. This part of the code will be executed for all the elements to its right. Okay, that is these things. Okay, I hope my point is very clear to what I'm doing. I am subtracting each element to my right from a common element, which is nums of I. Okay, see how it will be done. See, please pay attention here. Suppose I'm at three. Okay, what I will do 6 minus 3, which is 3. Okay. Then I will do 9 minus 3, which is 6. Then I will do 12 minus 3, which is 9. Okay. These are the things I'm going to do. Okay. Then I'm going to the difference. Okay. The difference is coming to. Remember, this term is changing because j is changing, but this term is constant because for every, for the whole, all of the j's, this I will be constant because I is the outer loop, right? So this I will be constant for each of the loops. Then I'm the difference I'm getting, right? Then I'm just searching if this difference, that is this tuple. Tuple means it's a combination of these two things. Okay, I and the difference. If it is a part of the answer, that is a part of the dictionary. Okay, let us not go through this case. So yeah, if it is not a part of, okay, I will just trace and show how it works. Okay, so please pay attention here. I will just trace and show how it works. Okay, initially, this is my answer. Okay, this is a yeah. And what will happen is, see, first 6 minus 3 will be done. Okay, what is 6 minus 3? Answer is 3. Okay, answer is going to be 3. What will happen here? The index is 1. Okay, index is 1. Yeah, index is 1 and the difference is 3. So this will be marked as a key all of its value, and because this was not existing already, so what will happen? So basically it will be allotted value 2. Okay, so it will be allotted value 2. Okay, now that's done. Okay, now come to the next case. See, like this all the cases will be there. Okay, 1 comma 3, then 2. I will just print and show you, that will be better for me. Okay, this error will come here. Just a second. I will just remove this part and I will done here. Yeah. So please try to understand this print statement is, after every ith loop. Okay. Once the ith loop ends, I am giving a print statement. So please try to see only the first output here. You will definitely get to understand everything here. Okay. For example, see, this one which is seeing here is basically the index, and this is going to be the difference. Okay, this I'm going to make it as a single key. Okay, this will tell me how many such sequences are there where we are going to arrive at the index 1. Okay, the index 1 with a arithmetic progression of difference 3. Okay, so in this case it is 2. Okay, in the first loop all the cases will be, it will be 2, because see, this condition, it will be true for every, see, every time when we are going to witness this for the first time, it will be true, right? So we will always start with a value 2. That is what is happening here. Okay, then on we will be progressing with a value 3, and then on we will be progressing with a value 4. Okay, that is what is happening. So what it means to say, see, at index 3 I have arithmetic progression with the common difference as 3. Okay, that's what it is. Okay, 3 minus 6, 6 minus 9, and then 12 minus 9, all that things. Okay, that's what is happening here. Okay, and if you talk about this value, it means that at index 3, that is the last index, there are two elements, that is the subsequence of length 2 with common difference 6. How it is possible? See, 6 and 12, right? If you talk about 6 and 12, the common difference is 6, right? And there are two elements, right? That's what they are mentioning here with this. Okay, this is what it means. And if you talk about this at index 2, okay, that at index 2 there is a length 3 of arithmetic subsequence. Okay, with common difference 3. How it is at index 2? Okay, 0, 1 and 2. So you can clearly see 3 minus 6, sorry, 6 minus 3, and 6 minus, sorry, 9 minus 6. These three elements form subsequence, right? That's what is being mentioned here. Okay, so that's what I'm doing basically. If you try to understand this code, what is happening is, see, there are three components here. Okay, suppose uh, it index I minus index j is equal to difference. Okay, so what I'm trying to do is, see, I'm going to save two of those values. Okay, so I'm going to save two of those values. Okay, I'm not saving the first. See, if you please pay attention here, jth index minus ith index now, and you are going to difference. Okay, I'm going to make this also as a part of the key. Okay, and the j also as a part of the key. Okay, that's what I'm doing. So the idea is, if these two are common, this also has to be common. Okay, that's the basic idea. So see, what I'm doing is, instead of calculating in a brute force approach, what I'm doing is I'm saving the approaches. Okay, so idea is, see, for example, 3 minus 6, you're getting from 6, you should continue, right? How to continue? That's what I'm doing in this here. Okay, so what I'm doing is from 3, I am subtracting from each of these. Okay, so I will get a starting start position. Okay, from there on, I will be continuing in each of the next sentences. Okay, so yeah, I'm just checking. See, this is the first case. Every time this will do when we are doing this for the first time. Then from the next time on, what we're doing is, see, if j comma difference is a part of the array, then take the I comma difference. See, this we will come to this case if this is there in the answer, right? So we will have this as a key, right? So we will utilize this answer and then we are adding one to it. Okay, that is, see, at already at index I, we had some value, right? Already at index I, there is a subsequence possible, and this is going to be the value of it. Okay, this is going to be the value of it. So I found another jth index also, which is going to have the same value as we are seeing here, right? So with that, I am going to add plus one. That is what is okay. So that's why you are getting, see, 3 comma 3 is answer 4. Okay, first you will have 2 comma 3 also. See, you are seeing here 2 comma 3. That means it's index 2 also it was possible. Then you will have 1 comma 3 where it is, yeah, 1 comma 3 one index 2, and yeah, this is the starting point. Okay, so yeah, friends, that was all. It's really fast solution, and yeah, I will just comment it out, and I will give this code to in the comments of the YouTube video. You can get it from there. And yeah, friends, that was really a fast solution, and yeah, I'm really happy that I got this kind of approach. If you find any other solution, they have done in different ways. Some are using prefix sum and something like that, but I felt this solution is really nice because without doing any such thing, okay, just with the over and square approach, I'm not using any other iterations or anything like that. We are getting the solution. If you talk about the time column, as you can clearly see, there are two for loops mentioned here. Okay, so it's basically over and square approach. But remember, the second for loop, it's not for the whole of n times. Okay, see, for example, the first one will run 0 to n. This, sorry, 0 to n minus 1. This will not run from 0 to n minus 1. Okay, so it's slightly less than that. Okay, so still it will be over and square approach. Now comes the space complexity. How to find the space complexity? See, this is the only thing which is consuming space. Okay, but how are we doing? For example, see, from 3 I will be subtracting all these elements. Okay, then from 6 I will be subtracting all these elements. Okay, so basically what I am doing is, it's just like that. Okay, how much of a time complexity is being used here, same time complexity will be used here, same number of keys will be mentioned here also. As you can see, they are printed and shown you, right? So this is the number of keys we are going to have ultimately. Okay, yeah, some of them will be repeating, that's true, but still, in the worst case scenario, this will be the number of times we run this both the loops, and the number of differences we save. Okay, each time, suppose there is some difference, so both will be same. That's why this space and time also are coming same. Okay, so yeah, friends, that was all for today. If you have a better approach, please do let me know. We can discuss it further. But if you have any doubts regarding my approach, please do comment below. We can discuss. Okay. But please try to understand this first, okay, how it is happening. See, I am trying to minimize the things. Okay, see, the same thing could have been done in a brute force approach also, using one more loop also. Okay, but I am doing some caching here. I am saving the results here. Okay, in terms of these things, why I'm using both of them, you will understand if you trace it. Okay, my advice will be trace this thing once. It will give you a lot of ideas. Okay, in the next question you can try those ideas, right? So yeah, friends, that was all for today. It was a medium question, and definitely there are a lot of approaches possible here. This kind of question. That's why in the starting itself I said this question will definitely will come in some of the interviews. Okay, because there are so many ideas possible here. You can dig a lot of deeper in it. Okay, when it comes to interview. Okay, so if you're practicing for interview, please have this kind of questions. Okay, you will definitely get benefit by it. Okay, thanks a lot. See you tomorrow.